how it's exposed is also important. There can be these windows of, I don't want to call them opportunity, but potential damage is greater when an organism is developing. So when the organ systems and nervous systems and hormone systems are developing during larval stages, you might have a higher degree of sensitivity than you would in an adult organism that's exposed, drawing on knowledge from chemical toxicity and risks there. So there's a lot of complexity. So this image here that I presented is a well, not this one, but the one I presented earlier. It's an oversimplification of trying to simulate data into an easy black and white yes and no answer. But you would have to definitely look in hotspots, in sensitive organisms.
All right, Martin, is there anything particular you would like to bring up of what we've heard so far?
Yeah, I would just like to sort of stress that many of these studies that have been published up until now, like you mentioned that some of them weren't really particularly relevant because they lack some kind of particle control or the settings aren't very natural. So, and also the fact that many of these studies employ very high exposure concentrations means that sometimes you would expect some artifacts in these experiments, and that's why it's also very important to have another particle to benchmark against to see, like, because we know that caloric restriction is one of the sort of main factors leading to the effects that we observe. So we need to sort of control for that at least. And in order to do so, we need some other particles that are not plastic. Or even look at mixtures of different particles. We also know that particles will interact with each other, they will form aggregates. If we also introduce organic material or biofilms in the system, you will have aggregations. And what's the actual dose in the end? So what you expose the animal to doesn't mean that that's actually what's coming bioavailable, which is also evident if you look at some dose responses or where people are trying to look at dose responses in experiments. You see that often they are not linear. And that's probably because of aggregates forming and so on. So these are, I mean, it's quite complex, and we already stressed that. So it's not as easy as you might think to carry out these experiments in a good way and interpret the results.